This is 8A.1.3 multiplication of complex numbers in the polar form. Let us have two complex numbers, z1 and z2, represented in the trigonometric polar form, where r1 and theta 1 represents the modulus and argument of z1, and r2 and theta 2 represents the modulus and argument of z2 respectively. We want to multiply z1 and z2. Taking this form, we simply perform the cross product of all these terms. r1 and r2 is brought out, and we have cosine theta 1 plus j sine theta 2 multiplying by cosine theta 2 plus j sine theta 2. We collect the terms, r1 and r2 brings out, and now we cross multiply all these cosine and j sine thetas together. We get this expression. If you remember the angle sum formula of cosine, you realize that this is simply this equation over here. And we can now reduce cosine alpha cosine beta minus sine alpha sine beta as cosine bracket alpha plus beta. So this is what we get for the real part. For the imaginary part, after we have collected together, we realize that this imaginary part is the sum of angles for the sine terms. So this expression can be found here, which is this sine alpha cos beta plus cosine alpha sine beta is sine bracket alpha plus beta, which is exactly this term. What we now realize is that if we want to perform products of complex numbers, we can of course do it in this long and complicated manner by expanding each terms together. However, we have now realized that we can simply remember this formula, which is that the modulus multiplies and the angle adds when we multiply z1 and z2 together. What is it graphically? Graphically, it looks like this. We have z1 over here, which is r1 theta 1. We have z2 over here, which is r2 theta 2. And when we multiply z1 and z2, the magnitude is z1 times z2. The magnitude is r1 times r2, and the angle is added. Okay, so simply if you actually want to see it in the polar form abbreviated, then this is even simpler. The magnitude of z1 and z2 are multiplied, the angles are added. That's it. Thank you.